Welcome back to HIM tutorials. Electricity and circuits is going on, and today we are going to do the subtopic electric bulb. And the learning objectives which we are going to cover for today's session is that we will see who had discovered the electric bulb, then we will see the structure of the bulb, and we will discuss some important points related to the bulb. So let's begin. As the bulb for the first time it was given by Thomas Edison in 1878, and it was very revolutionary. You can say it is very revolutionary discovery in the history of science, because before that we had no such a source which help us to see in the darkness. So let's begin with the structure. As I made all the diagrams before you live so that it would be easy for you to draw on your notebook along with me. You can try for this. You have to make such kind of extensions. Now you have to go for the outline bulb. It's the bulb casing. It has 2 points, contact points, and in between it has thick glass. Also there is extension of the contact points with the wires. It has 2 support wires then, and these 2 support wires has got the highly coiled filament in it. Also the wires are extended and they are just giving the support to the tungsten filament. So it is a rough diagram of the structure of the bulb. Now let's label it quickly. This is the contact point. Now these are 2 holder pins. This is the metal covering. It is a thick glass. These are the supporting wires. They are conductors, and we know that conductors are helpful in conducting electricity. It is a filament. It is made up of tungsten, very important part of the bulb. So this part which is empty, and between the tungsten and the outer thin glass, this is filled with gas called as argon or nitrogen, and they both are the inert gases. And this outer casing is thin glass bulb. So it has 2 contact points in it, and with the help of 2 contact points the bulb is connected with the 2 terminals, and there is both on both the sides there are holder pins, and with the help of this holder the bulb got fitted up into the socket and get locked. Then it has a metal cover, and beneath the metal cover, under the metal cover, there are 2 extension wires which are helpful in carrying the current to from the thick glass to the supporting wires, and from the supporting wires the current will start flowing into the tungsten filament. So this is the basic structure and the basic label diagram, a typical cell, a typical bulb of the times of the ancient times which we are using. Most commonly we are using it in today's scenario also. So let's see what are the main points in it. As it is discovered by Thomas Edison in 1878. Also this bulb is called as the filament bulb. Filament bulb, and incandescent bulb also. Incandescent means any material which is capable of emitting the light when it is heated up. So mainly the metals, when they heat up, they emit the light. So tungsten is somewhat also very, it's a slightly good conductor of heat and electricity. So when it is absorb the energy in the form of electricity or in the form of charge, it starts emitting the light, it starts glowing. So that's why it is the incandescent material. So that due to that incandescent material, it is called as the incandescent bulb. And the basic principle on which the bulb depends, that is, it's convert the electrical energy to the light energy. And along with the light, some amount of heat is also emitted. Nowadays we are using CFL, we are using LED lamps, and these LED and CFL and many more other kind of bulbs emit large amount of heat and less amount, large amount of light and less amount of heat. But this typical bulb emits large amount of heat also and comparatively equal amount of light also. Okay, so the next main point in the bulb is that it has a special filament which is called as the tungsten filament. Now here the main question is arise that why only the filament which is present in this bulb is in such a coiled position. Why, if you see the bulb and you visualize the bulb from very closely, you will see that this filament which is present inside the bulb is having number of turns in it. It is not a thin wire, it is having number of turns in it. So why the bulb, the Edison who had developed the bulb make the such a structure, coiled structure of the filament. So so the answer to this question is that if it takes a single wire like this, so he has to go for very big structure of the bulb, and he wants to just compactify, or you can say he want to make a compact form of the bulb. So that's why he take the wire which is having number of coils in it. It has one more property also, this filament, that it is having high resistance. High resistance means that kind of material which is not allowing easily to flow of electric current through it, and that material which is not allowing easily to flow electric current through it will start heating up, and as finally when it is very hot, it will emit light in the form of light energy. So this filament, as I told earlier, it is a good conductor but still having high resistivity. These are two very unreliable things, because generally the conductors are not having very good resistance in them, as the wires which we are using in our household circuit. So they are having just copper wires or aluminium wires, or not aluminium but copper wires are used mostly. So copper is very good conductors, and conductors do not resist the flow of electric current, because if they resist the flow of electric current, the wire will heat up, it melt, it breaks, and it may sometimes it may catch fire also. So it is very dangerous. But here the tungsten filament is used. It is good conductor but having but also having high resistance. And why it is having high resistance? Because the wire which is used in it has two properties. It is very thin and having number of coils in it. So due to these two properties, the filament which is used inside the bulb is having very high resistivity or having very high resistance. Again I repeat, what is resistance? Anything which does not allow the easy charge of the electric current through it. कोई भी ऐसी चीज़ जो अपने में से इलेक्ट्रिसिटी को ईजिली पास नहीं होने देती, उसी चीज़ को हम लोग बोलते हैं, उसी प्रॉपर्टी को किसी भी मटेरियल की हम लोग बोलते हैं रेजिस्टिविटी, रेजिस्टेंस. So same is the condition here, that मेनली जो है वो कंडक्टर्स कम रेजिस्टेंस प्रोवाइड करते हैं, इंसुलेटर्स ज़्यादा रेजिस्टेंस प्रोवाइड करते हैं, लेकिन द टंगस्टन इज गुड कंडक्टर ऑल्सो एंड हाई रेजिस्टेंस ऑल्सो. Why good conductor? Because it is helpful in flowing the electric current. Second thing, it is having high resistance. Why? Because the wire which is used having number of coils in it, and it is very thin wire. Okay, so both the properties are there in the tungsten. Third main property of the tungsten is that it is having very high melting point. Melting point. Now what is this melting point? Melting point means that kind of point which helps to melt the material and change state from one form to another. For example, we boil the water, and when we boil the water it changes from liquid to vapors, so it is a vaporization, it is a evaporation. Okay, when we heat up the ice, it will start melting, so it's changing from solid to liquid. So same is the condition, that melting point means that point of any kind of material at which it starts melting, and the tungsten is having very high melting point, and that is from 2200 degree Celsius to 2900 degree Celsius, even up to 3422 degree Celsius, which is 6192 degree Fahrenheit. So it is 6192 degree Fahrenheit. So this is the highest melting point, so that's why we are using tungsten here, because when very high amount of electric current passes through it, then due to this high melting point it does not melt. Okay, now the third main thing which is present in the bulb is that the bulb and the outer layer of the bulb, the tungsten and outer layer of the bulb, which is made up of glass, in this part there is presence of an inert gas. Now the again question arises, why inert gas is used, why not air is used here? So if we see the composition of air, in air it is having 78% of nitrogen and 21% of ऑक्सीजन, मतलब एयर के अंदर इतना परसेंट नाइट्रोजन है, इतना परसेंट ऑक्सीजन है, और ऑक्सीजन जो है वो सपोर्ट करती है बर्निंग को. ओके, सो व्हाट विल हैपन इफ दिस एरिया इज फिल्ड विद द एयर, देन देयर विल बी प्रेजेंस ऑफ ऑक्सीजन. देन इफ देयर इज प्रेजेंस ऑफ ऑक्सीजन, अगर वहाँ पे ऑक्सीजन होगा, देन टंगस्टन विल रिएक्ट विद द ऑक्सीजन. व्हाट विल हैपन? टंगस्टन reacts with the oxygen and it will give tungsten oxide, and this tungsten oxide doesn't have a long life. After few days it will broke off and it will just lead to fused condition. कौन सी condition आएगी? Fused condition हो जाएगी. क्यों? क्योंकि जो wire है it will heat up, and as it will heat up it will start reacting with the oxygens, because many many elements are there, when they are heat up at very high temperature they start reacting with the oxygen. Tungsten is also one of them. So tungsten will when heat up it will react with the oxygen, it form tungsten oxide, and after some time this tungsten oxide will lead to thinning of the wire. Wire जो है वो बहुत पतला होता जाएगा. पतला होने से क्या होगा? अ टाइम विल कम व्हेन इट ब्रोक्स फ्रॉम द मिडल एंड द बल्ब गेट फ्यूज्ड. बल्ब फ्यूज हो जाएगा. हम लेमन लैंग्वेज में भी इसको बोलते हैं कि बल्ब फ्यूज हो गया, वो वर्क नहीं कर रहा. तो अगर वर्क नहीं करेगा देयर वुड बी नो लाइट. ओके, नाउ अनदर मेन पॉइंट हियर इज दैट इफ द स्पेस हेयर इज नॉट फिल्ड विद द एनी काइंड ऑफ एयर, मान लो इस स्पेस के अंदर कोई भी एयर नहीं होता, इनर्ट गैस भी नहीं होता, ठीक है, द आउटर कवरिंग एंड द इनर टंगस्टन, in between this part there is no air is present, and if there is no air is present then it would be a vacuum condition. क्या होगा वहाँ पे? vacuum condition होगा. And if the vacuum condition is there, then what will happen? The electricity is given to this bulb, okay, and due to the electricity the filaments start heating up. It will lead to very high temperature. And what happen if there is vacuum? Then that time this tungsten filament starts evaporate. Okay, it starts evaporating, and once it starts evaporating, it will lead to accumulate a black fume layer over the inner surface of the glass bulb. क्या होगा कि ये बहुत हीट अप हो जाएगा, हीट अप होने से ये इवेपोरेट होना स्टार्ट हो जाएगा, कौन, टंगस्टन, एंड जब वो इवेपोरेट होगा तो ये ब्लैक फ्यूम्स फॉर्म करेगा, और वो ब्लैक फ्यूम्स जो है वो सारे ब्लैक फ्यूम्स जो हैं जो इनर सरफेस है bulb का, it starts accumulating there, and if it starts accumulating there, then what will happen, the bulb will not emit light properly, and the main purpose why the bulb is formed, to get the light, and if there is no light, then there is no use of bulb. Okay, so it will lead to evaporate the filament. Okay, now the next main point is this, that we have done with that why the tungsten filament is there, we have done that why this part is not empty. Now the question again arises that why the inert gas only is there, why not any other gas? So to answer this question I will tell you, inert gas is non-reactive, and if it is non-reactive, then it will not go under it will not go for any kind of chemical reaction. It will not go for any kind of chemical reaction. Okay, inert gas is non-reactive. If it is non-reactive, it doesn't go for any kind of chemical reaction, and it act as a insulator between the tungsten and between the glass bulb. Okay, so I hope you understand all the basic points that हमने क्या स्टडी किया. थॉमस एडिसन ने 1878 में इसको इन्वेंट किया. फिलामेंट बल्ब भी बोला जाता है, इनकैंडेसेंट बल्ब भी बोलते हैं इसको. वाई? बिकॉज इट इज हैविंग सच काइंड ऑफ मटीरियल विच emits light at very high temperatures. Okay, it changes electrical energy into the light energy. Then it has a very important part that is called as the tungsten filament. Why tungsten filament is taken? It is a good conductor and also having high resistance. Okay, why high resistance? Because it has thin wire and has number of coils in it. And why the again there is one question also, that why this filament is not in a straight line, why it is having coils? So the answer to this question is, if it is having a long this kind of structure of a wire here, then what will happen, it will lead to form a very large structure of the bulb. बहुत बड़ा structure एडिसन को बनाना पड़ता. So he just want to compact the size of the bulb, he just make turns in it, and due to the turns what happened, the tungsten filament has got number of high power of resistance in it, and if there is more resistance, then more heating effect, and due to the more heating effect there is more emission of the light. So high melting point is also there. How much? 2200 degrees Celsius to 29 degree 100 degrees Celsius, and also it can raised up to 3422 degrees Celsius, which is 6192 degree Fahrenheit. So such a high melting point. Due to this high melting point, it don't breaks easily. Okay, then the next point is that अगर फिलामेंट के बाहर जो है वो ऑक्सीजन होता या एयर फिल्ड होता, तो एयर के अंदर क्या है, देयर इज कंपोजिशन ऑफ नाइट्रोजन ऑल्सो देयर इज कंपोजिशन ऑफ ऑक्सीजन, देयर इज पीसेस ऑफ ऑक्सीजन देयर ऑल्सो. सो व्हाट विल हैपन, नाइट्रोजन इज इनर्ट, वी नो दैट, बट the tungsten will react with the oxygen. If the tungsten will react with the oxygen, it will form the tungsten oxide. It will lead to further more thinning of the wire, and a time will come when the tungsten wire breaks down. Okay, then it will lead to next condition, that if the air is not present here, if the air is not present here and vacuum is there, okay, means no air is there, then what will happen, at that time the filament starts evaporating at very high temperatures, and due to that evaporation there is accumulation of black fumes inside the inner part of the bulb, and the emission of the light will not be proper. Then the last point is this, that the bulb has got inside it inert gas, either it is argon or nitrogen, but inert gas is present. Why inert gas is present? Because the inert gas is non-reactive and it doesn't undergo any kind of chemical reaction. So it is acting as an insulator between the tungsten and between the glass bulb. So I hope you understood the basics, what is the basics inside this structure of the bulb. And in next session we will discuss that how this bulb we are going to connect it with the circuit symbols and little more. So up to then, keep watching, keep learning. Thank you so much.